In real life, there's often missing information about the genotypes of the parents. This can make a problem seem impossible to solve. What do we do if the information that we're given is for the inside of the square and we don't know what goes on the outside of the square? Well, in this case, we're going to still use those 5 steps for solving a Punnett square. We simply may not do them in the same order that we do when we have the information about the parents. So again, we're going to start by reading the problem. In doves, a plain beak is dominant over a striped beak. A dove with a plain beak was mated with a dove with a striped beak. 50% of the baby doves had plain beaks, and 50% of the doves had striped beaks. What were the genotypes of the parents? So first we're going to start with our key. It tells us that plain beak is dominant. So our dominant allele is plain. It also tells us that our other trait, our recessive trait, is a striped beak. So we're going to put that in our key. Next, they do tell us something about the parents. We have one parent having a plain beak. So I'm going to write for parent 1 that the phenotype, because the phenotype, remember, is what it looks like, is plain. And our second dove, the second parent, has a striped beak. So we're going to write striped here. Now, this information right here, the fact that the parent has a striped beak, tells me something about the genotype. Because striped is recessive, the only way I could have a striped beak is if one parent is little a. So I know that one parent is little a. Now, the other parent is plain, which means they have one dominant allele. That's why they're plain, but we don't know what the second letter is. It could be that this parent is big A, and it could be that this parent is big A, but we don't know which one. Now, the next thing that I would do in a regular problem is do the Punnett square, and I'm going to do the Punnett square as far as I can. I know that one parent is little a, so I have that information. I know the other parent is big A something. So I'm going to fill out my Punnett square with the information that I have. So I know that this is going to be big A, and this will be big A, and then this A is going to go over here, but I don't know what the other letter is, right? Because this guy is going to go down here. And this offspring will also have a little a and a blank. So now I'm going to look and see what they tell me about the children, because this is something that's really happened. And we know that 50% of the baby doves have plain beaks. Now remember that the plain beaks have a big A in them. So this would be plain and this would be plain. So I've got my 2 out of 4, which is my 50% of plain offspring right here in this row, which means that I need the other half of the offspring, which are 50% striped. Now, striped is recessive. So in order to have a 2 striped, I need to have little a's right here. So that means this is going to be a little a. That's going to give me 2 out of 4 striped, which matches with what they tell me in the problem. So I now know that this parent right here is a big A, little a. And because the question is asking what were the genotypes of the parents, I have those genotypes right here. Here's the genotype of parent 1, and here's the genotype of parent 2. So let's try another problem. If you would like to try this independently, pause the video now, work the problem out, and then come back for the explanation to check your answers. In tropical fish, shiny scales are recessive to dull scales. A clutch of eggs from a pair of tropical fish were hatched, and 25 of the baby fish had shiny scales. What were the genotypes and phenotypes of the parent fish? Let's start with the key. It tells us in the problem that shiny scales are recessive. That's going to be my little a. So my little a are shiny scales, and my dominant are dull scales. The problem doesn't tell me anything about the parents, but it does tell me something about the offspring. It tells me that of the baby fish, 25% had shiny scales. Now, shiny is recessive. So this 25% is 1 out of 4 of my squares in my Punnett square. Shiny scales are recessive. You can see that right here. So in order to have that, these offspring need to be homozygous recessive. So it's 1 out of 4 squares, so I'm going to put it right here. That's going to be a little a, little a. Now we use what we know about patterns of Punnett squares to figure out how those 2 little a's got there. One of those little a's came from up above, and the other little a came from the side. So now I know 2 of the letters, 1 from each parent. This A is not only going to fill up that bottom box, but it's also going to put one of its alleles in the box above, as is this guy right here. So now I know 2 other letters in my square. So now I'm going to go back to my problem and realize that I've only filled out 1 out of the 4 boxes. The other 3 boxes, the 3 out of the 4, are going to not be shiny, which means they have to have a big A in them. So that means a big A is going to need to go here to send a big A to this box. It's also going to put a big A here. Now, I also need this box right here to be a big A box, so I'm going to put a big A right here. Now, when I do this, it's going to fill out the rest of my box. So now I know the genotypes of my parents. This parent right here is a big A, little a parent, and this right here is parent 2, also a heterozygous. If they are heterozygous, they have 1 dominant allele. That means that they are going to have the dominant trait. Both parents are big A, little a, and both parents will be dull scaled. So I have now answered the question, what are the genotypes and phenotypes of the parent fish? Let's do one more practice problem. If you would like to do this one independently, please stop the video. When you finish the problem, then turn the video back on to check your answer. The ability to smell asparagus in your urine is recessive. Even though their father has the ability, none of his 12 children have the recessive trait. What is the likely genotype and phenotype of the man and his wife? First, we'll make the key. The trait is the ability to smell asparagus in your urine, and it is recessive. I'm going to abbreviate this by calling this a smeller. The dominant trait is to be a non-smeller. The next thing that we're going to do is take a look at the problem and see if it tells us anything about the parents. We don't see anything about mom, but we know that father has the ability to smell the urine. That makes parent 1 a smeller. Now, in order to be a smeller, because this is a recessive trait, dad will need to be a homozygous recessive. If he had any dominant trait, if he was heterozygous or homozygous dominant, he would be a non-smeller. The father's genotype is the only thing we know about the parent, so we're going to put this homozygous recessive genotype on our Punnett square. And we're going to do what we would normally do with a Punnett square, which is to put our genes in each of the boxes. So we're going to have a little a here and a little a here, and we're going to have a little a here and a little a here. Because I don't know mom's genotype, this is as much as I can do on the outside of the square. So I go back to the problem, and I can see that none of his 12 children have the recessive trait. That means that they all have the dominant trait. And right now in the square, I can see only recessive traits. So there need to be dominant alleles in each one of those boxes. So to put dominant alleles in the first column, I need to have a big A. That is going to be a big A here and a big A here. And that means this square and this square will now be non-smellers. I have to do the same thing over here by putting another big A here. That means this square and this square will also be non-smellers. And since all of the children are non-smellers, this box now represents the children. So now I know mom's genotype. Mom is homozygous dominant. So I'm going to put her homozygous dominant genotype over here. And because she is big A, based on my key, she is also a non-smeller. Now, each of the children, they are also non-smellers. They just happen to be heterozygous, unlike the mom or the dad. So now I've solved the problem. The problem is, what is the likely genotype and phenotype of the man and his wife? I know that the man is homozygous recessive, right? This guy right here. And the mother is homozygous dominant. Now that we've learned how to solve these problems, I'm going to ask you to do the practice problems on your sheet. The key is posted on Schoology, so when you finish doing your practice problems, check to see if you've done them correctly. And remember that you can always ask for help if you're having trouble.